Earth's unrest. What is an earthquake? Our planet is a vibrant, ever-changing place. While we go about our daily lives, deep beneath our feet, a constant geological drama unfolds. The Earth's crust, that seemingly solid ground we stand on, is actually a mosaic of giant pieces called tectonic plates. And these plates are always on the move, albeit very slowly. An earthquake is a sudden, often violent shaking of the ground. Imagine dropping a pebble into a still pond. The ripples spreading out from the impact point are like the seismic waves that travel through the Earth during an earthquake. These waves are generated when tectonic plates, those massive pieces of Earth's crust, move against each other. The intensity of an earthquake can vary greatly. Some are so slight that they can only be detected by sensitive instruments. Others are powerful enough to level entire cities, leaving behind a trail of destruction and despair. But no matter the magnitude, all earthquakes are a testament to the immense power that lies hidden within our planet. Shifting giants, the dance of tectonic plates. To understand earthquakes, we must first delve into the world of tectonic plates. Picture the Earth's crust as a giant jigsaw puzzle, with each piece representing a tectonic plate. These plates are not static. They are in constant, albeit slow, motion. The plates float on a layer of semi-molten rock called the mantle. Heat from within the Earth creates convection currents in the mantle, causing the plates to move much like rafts drifting on a slow-moving river. Most of the time, this movement is gradual and imperceptible to us. However, the boundaries where these plates meet are zones of immense pressure and friction. It is at these boundaries where most earthquakes occur. Think of it like pushing two rough rocks together. They might grind against each other for a while, but eventually the pressure becomes too much and one or both rocks will slip, releasing energy. When plates collide, the birth of an earthquake. As tectonic plates move and interact, they can collide, pull apart, or slide past each other. Each of these interactions creates different types of faults and can trigger earthquakes. When plates collide head-on, they can buckle and fold, creating mountains like the Himalayas. This process is slow and usually doesn't cause major earthquakes. When plates slide past each other horizontally, they can get stuck due to friction. The pressure builds until it overcomes the friction, causing the plates to slip suddenly. This sudden release of energy sends out seismic waves that shake the ground, resulting in an earthquake. The San Andreas Fault in California is a prime example of this type of plate boundary. The point where the earthquake originates within the Earth is called the focus or hypocenter. The point directly above the focus on the Earth's surface is the epicenter. The closer you are to the epicenter, the stronger the shaking will be felt. Section 4, measuring the tremors from minor shakes to catastrophic quakes. Scientists use a tool called a seismograph to detect and measure the strength of earthquakes. The seismograph produces a visual record of the seismic waves, called a seismogram. This record helps scientists determine the magnitude of the earthquake, which is a measure of the energy released. The most commonly used magnitude scale is the Richter scale. It's a logarithmic scale, which means that each whole number increase on the scale represents a 10-fold increase in the amplitude of the seismic waves and a 32-fold increase in energy released. For example, a magnitude 6 earthquake releases 32 times more energy than a magnitude 5 earthquake. Earthquakes with magnitudes below 2.5 are usually not felt by people, while those with magnitudes of 8 or higher can cause catastrophic damage. Section 5, the aftermath. Earthquakes' impact on humanity and infrastructure. Earthquakes are a stark reminder of the immense power of nature and our vulnerability in the face of it. The impact of an earthquake depends on several factors, including its magnitude, depth, distance from populated areas, and the quality of building construction. The most immediate and visible impact of an earthquake is often the damage to buildings and infrastructure. Ground shaking can cause buildings to sway, walls to collapse, and bridges to crumble. Earthquakes can also trigger secondary hazards like landslides, tsunamis, and liquefaction, where the ground behaves like quicksand. Beyond the physical damage, earthquakes can have a profound impact on people's lives. They can cause loss of life, injuries, displacement, and economic hardship. The psychological trauma of experiencing an earthquake can also be significant, leading to anxiety, PTSD, and other mental health issues.